Hello there. This video is to show you how to solve this system of equations by using substitution. Enjoy. All right, so we've got the equations y equals 2x minus 4, 3x plus 4y equals 17. This is a system of equations because there are two or more equations. So as we solve this, I'm going to show all of the work on this left side, write out the steps that we can hopefully use in future problems on the right side. So when we solve a system of equations by substitution, the very first thing that we need to do is to isolate a variable, if necessary, right? In some systems of equations, you will be given an isolated variable. In some equations, you'll have to, or in some systems, you'll have to create an isolated variable. Now, hopefully you know what isolate means, but if not, you need to make an equation have a variable all by itself. So you need to isolate a variable, making an equation either x equals or y equals. Okay, so if we look at the problem that we've got over here, y equals 2x minus 4, 3x plus 4y equals 17, we have an isolated variable already. So step one, we don't have to do anything. Step one is already done for us, right? And so we have this isolated variable. This y is all by itself. This y, it's y equals, right? That means it's by itself. It is isolated. Okay, so step one is to isolate a variable. Once you have an isolated variable, we should make that the same color. Hopefully I can do that without too much work. Apparently I need to retype it. That's okay. If it'll let me. There we go. Right, this y is isolated. It's all by itself on a side of the equation. All right, so step two, once we have an isolated variable, we're going to box the other side. That doesn't mean you're going to try to punch it, right? You're going to put a box around the 2x minus 4. Let's get our rectangle tool. We don't want to fill the shape because we still want to be able to see it. So we have an isolated variable. That's already done. If we weren't given an isolated variable, right, we have talked about and practiced isolating variables for 2 modules now, right? When you have an equation and you solve for y, that is isolating a variable. Okay, so we boxed the other side. We did that. All right, this is easy. Look at that. We found an isolated variable. We drew a box. All right, so step 3 is we are going to substitute the box into the other equation. Hence the name substitution. We're substituting, and it has the name substitution. Ah, so nice when math rules have names that make sense. And one thing that students often struggle with is they're like, oh, I don't know where to substitute it, right? If it's equal to y, like it is in this case, right? So y equals 2x minus 4. So it's equal to y. Plug in for y or substitute for y. Let's use substitute. And same thing, if it's equal to x, substitute in for x, right? But so this 2x minus 4 is equal to y. Now, in a system of equations, right, the y's in these two equations have to be the same, right? So this y is equal to this y. They have the same value, right? Just like the x in each equation is equal. They have to have the same value. Okay, so this 2x minus 4 is equal to this y, which also means it's equal to this y. So we're substituting this 2x minus 4 in for the y in the other equation. So what does that look like? Well, let's see. So we have this second equation, that's 3x plus 4. But now instead of y, we're substituting this 2x minus 4 in for y. And when you substitute, you need those parentheses. So this 2x minus 4 is replacing the y. And it, right, this is that bottom equation, 3x plus 4y equals 17. So again, we've taken the 2x minus 4, substituted in for y in the second equation. Okay. Now, we're going to pause for a moment, and I'm going to go back here. Because our goal when solving systems of equations algebraically is to create one equation with one variable. Apparently I'm editing the background the whole time. That's okay. Right? The goal we just said was to create one equation with one variable. If we look at this equation right here, this equation, there's only one equation there, and it only has x's. That means we're doing it right. Our equation doesn't have an x and a y anymore. It only has x's, and that is the goal. Right? So we've created an equation that only has x's. Write ourselves a reminder. This should be an equation with one. Okay. So we've created this equation that only has x's in it. And guess what we get to do next? If we have an equation that only has one variable, we now know how to solve that equation. So step 4, solve the equation. Right? So that equation work that we did earlier in the year, still using it. So as we solve this, hopefully we recognize, oh, we're going to have to distribute this 4. We're going to have to multiply the 4 by everything in those parentheses. So when we do that, we have 3x plus 4 times 2x is 8x. 4 times minus 4, 4 times negative 4, negative 16. It still equals 17, right? So we're solving, right? We have the 3x and the 8x, right? These can be combined. They're like terms. So those combine to 11x. And we're still solving. We now have all the left side simplified. So we need to get the x by itself. So we need to move the 16 to the other side. Because we're trying to get the x by itself. We have 11x equals, we're still solving, right? We're not adding steps over there because we're solving the equation. We need x by itself. So we need to divide both sides by 11. Make sure we show we're dividing here. And look at this, we are still solving. Now we get x by itself. And 33 divided by 11 is 3. Whew, that was a lot of work. And guess what? We are not done, right? This is a system of equations. So hopefully we remember that our solution is an ordered pair, right? We're finding the point of intersection of two lines. Whether we use graphing, substitution, elimination, we're finding an ordered pair where the lines intersect, where the lines cross. We only have the x so far. So now we have the x. That means we need to plug it back in to find y. And this is where Mr. Barron is really proud of himself. Years ago, he came up with this. Step number 5. Go to back in the box. Right? Sounds like Jack in the Box, but it's back in the box. Why do we choose back in the box? Like Jack in the Box, it's open 24 hours a day, which is always a good thing. Right? And they have great variety at Jack in the Box. So who wouldn't want to go there? Good breakfast, lunch, and dinner, open 24 hours a day. Great place to go. So we're going to back in the box. So we're going to take the answer and put it in the box. Okay, so what that means, we just found out that x is 3. We're going to take that 3 and we're going back in the box. Back in the box. All right, we now know that x is 3, so we're going to plug that 3 in for x. And guess what we do from there? We solve. Right, so solve for the other variable. In this case, we're solving for y since we already know what x is. Right? At the beginning, we could have had the equation that was x equals, and we could have solved for y first. Doesn't matter. But now we're solving for the other variable. Y equals 2. Look at that. We have our x. We have our y. We have everything we need, thanks to back in the box. Now, this last step isn't really a step, but it's an important one. Step 7. Write your answer as an ordered pair. Again, ordered pairs are always x, y. So our solution, our x is 3, our y is 2, 3, 2 is our solution. Boom, shakalaka.